see you there.
Hi, I'm Kate. Today I'm going to be telling you about microplastics with Olivia, who you'll meet in a second. But what are microplastics, and why do we care? We care because they affect fish, but more on that later. So microplastics are large plastics that have broken down into really small plastics, or they're things that you might find in things like your body wash, your face wash, your dental floss, or even your super cool polyester shirts. Who's got it better than us? Clean Oceans, that's who. More on how they get there from Liv.
So how do microplastics get into the oceans? Some of it is from marine pollution that's breaking down, and some of it is from those products Kate just showed you, which are too small to be filtered by the municipal water systems. So, do all drains lead to the ocean? Maybe not for Nemo, but that's where a lot of our microplastics end up. Why do we care? Because it affects the fish we love.
So, while we can't say for sure how microplastics affect fish, we can tell you about two studies that we reviewed recently. And actually, you've just caught me reading one. This study is about Japanese Medaka and how microplastic pollution has affected their hormone regulation. So, endocrine disruptors, which microplastics are perceived to be, are chemicals that interfere with hormone regulation. Fish are really good at expressing this based on changes in their growth and health of reproductive organs, so your gonads, sex-specific gene protein induction, and the occurrence of intersex. What is intersex? It's when a fish shows germ cells that are both male and female. So this actually occurred in the Japanese Medaka. There were males that were showing both male and female characteristics. Isn't that crazy? Well, that's pretty important because that could affect population dynamics. But couple that with how microplastics affect food chains, you've got a real mess. More on that up next.
Studies also show microplastics significantly reduce zooplankton growth, reproduction, and survival. In addition, the findings support the notion that plastics interfere directly with feeding by larval or juvenile fishes, potentially blocking digestive tracts or otherwise not allowing for proper digestive function. So, when there are less surviving plankton, there's not only less food for secondary, tertiary, and quaternary consumers, this also has the potential for biomagnification up the food chain, meaning an accumulation of microplastics in the top predators. Germ cell effects and bioaccumulation? Doesn't sound great, right?
So, more research is needed on microplastics and their effects on fish.
So stay tuned.
I've lost the contact!
We've lost contact.
Your contacts? So what's next? I don't know, I wasn't sure.